thinking about quantum mechanics. Okay, so how are we going to get to my tale of a stained glass? Well, my tale of a stained glass isn't about this. It is about studying these supercooled liquids and saying, well, all of the other experiments, they average over a tremendous number of molecules, and they average over time in a way that we don't like, and we can't pull out these details about spatial and dynamic heterogeneity. In fact, when you've got what people think is a grossly heterogeneous system, it would be best if you could isolate and interrogate each molecule on its own. Unfortunately, we can't do this, but we do the next best thing, which is we stain our glass. We stain our supercooled liquid. In fact, it's a doped supercooled liquid. So what do we put in there? We put these big red ellipsoids in there. They're not that big, and well, they are kind of really red. And we watch what they do, and we hope that they're good reporters of what's happening in the rest of the system. Okay? So, in doing this, we're unfortunately blind to the supercooled liquid molecules that we would really like to study, but we can see these red molecules, which are very dilutely sitting in the supercooled liquid. And so what would we see if we have spatial heterogeneity and these probe molecules, or staining molecules, are telling us that we've got spatial heterogeneity in the system? So we said, if we have spatial heterogeneity, we've got some areas that are moving slowly and some areas that are moving quickly. So if that's true, and this is actually what we look at molecules rotating. So we're going to see some of these probe molecules rotating slowly and some of them rotating quickly, if there is this spatial heterogeneity in glasses. And if there's temporal heterogeneity, what we should be able to do is watch one, and over time we should see that its dynamics change. So that's exactly what we try and do. And so here are two possible explanations